Today we're going to take what we learned in our last class and apply it to find the missing sides of right triangles. You're going to remember that what we discovered was called the Pythagorean theorem. It only works for right triangles, and it basically says that if you sum the squares of the two legs of a right triangle, it will equal the third longest side, called the hypotenuse, squared. And here is exactly what I was just saying. So here's your right triangle. Note the little square in the corner lets us know that that's a right angle. And here is the Pythagorean theorem stated in a much just abridged, concise form. It's a squared plus b squared equals c squared, where a and b are the legs in a right triangle and c is the hypotenuse. So it describes the relationship between the lengths and legs of every right triangle. And what you can do with this is use that to find the missing length of one of the three sides. We're going to start by trying to find the hypotenuse in a right triangle. So I've drawn one here. You can see the two legs. Those are the two sides that make up the right angle. A and B are the letters that we usually use to describe them. They are the legs. Now, the third side, which is opposite the right angle, it doesn't touch that angle. It doesn't make up one of the sides of the right angle. That's called the hypotenuse. So if we take one of the legs and square it, add it to the other leg squared, it will equal the hypotenuse squared. In other words, a to the second power plus b to the second power equals c to the second power. So if I was to give you the length of A, and I measure it and tell you how long it is, and I tell you what the length of B is, you can use Pythagorean theorem to figure out what the hypotenuse is. And that's what we're going to walk through right now. Now, in your book on page 412, first of all, they're letting you know about the little symbol for a right angle, which is this, makes it look like a little square once it's put in the corner. The little square will let you know that those are the two sides that make up the right angle. So in this triangle, in number one, that we're going to find the missing side. Notice it doesn't have a number, it has a variable, it's an unknown. So we're going to take one of the legs here and the other leg, and we're going to substitute them into Pythagorean theorem. It doesn't matter which one A or B is, but it does matter who C is. So we're going to call the 12A. So we're going to take 12, one of the legs, and square it. We're going to add it to the other leg, call it B, square it, and that has to equal the hypotenuse squared. The next thing we're going to do is pick up our calculator. We're going to take 12 to the second power. Now, you shouldn't write 24 here. It's 12 times 12, or 12 to the second power is 144, plus 9 to the second power is 81, and that's going to equal c squared. And this is the way your work should be shown, okay? So you should show the substitution, and then square the 12, write it down, square the 9, write it down, and then put equals and still put c squared here. Now you're going to add 144 plus 81, that's 225. That equals the hypotenuse squared. And I need everybody to listen right now, because the number one mistake is to stop and say that the length of the hypotenuse is 225 inches. How can that be? There is 9 inches and 12 inches. How could something that is 225 inches connect those right there? Okay, that's the number one mistake. That is not C. That is c squared. That is representing the square, like we talked about the other day, of the hypotenuse. Not the hypotenuse, but the number of, remember, the square units, the area. So we need to undo that squaring. And we learned that the opposite of squaring was to take a square root. So we're going to take the square root of 225. I'm allowing you to use the calculator, but some of you might recognize that he is on the perfect square trail. He is a perfect square. So we're not surprised that we get a whole number. Now remember that there are two roots. There are two possible numbers that when you square them, they give you 225. 15 to the second power is 225, and negative 15 to the second power is 225. We're not going to talk about the negative root, though, because this is the length of a side of a triangle, and it can't be a negative unit. So we are not going to pay attention to the fact that there could be a negative answer here. So our final answer would be 15, and don't forget to put your units in there, 15 inches long. That's how we use Pythagorean theorem to find the missing hypotenuse. Now down here you can see you can check your answer once you get the 15. You can go back up and make sure that this equation works by putting the 15 in. And that's kind of what they're doing here. They're doing like a check. Hey, did I get the right answer? Did I accidentally hit the wrong number in the calculator? So you can kind of check and make sure 12 squared plus 9 squared, that's 225, and 15 squared equals 225. So surely enough, that is the right answer. Final answer, 15 inches long. So I want you to really pay attention here. We're going to do this one together, and I really want you to see the work, and then I'm going to have you try 2 on your own, okay? This is on page 113, and it's the got it A. So the first thing I notice is that the longest side, the hypotenuse, is missing. I'm going to use Pythagorean theorem. And by the way, they could have called this anything. It could have been D, it could have been Q, but usually in Pythagorean theorem, people will use C for the hypotenuse just so we kind of are all on the same page. So I'm going to take leg plus leg. And I don't know if yours shows it. Sometimes when I copy it from the online textbook, the little square goes missing. But this is a right angle, and I should have put that in there for you. All right, so we're going to take one of the legs, square it, plus the other leg squared is going to equal that hypotenuse squared. So the first thing we're going to do is leg squared plus leg squared equals hypotenuse squared. The next thing we're going to do is we're going to take 24 to the second power in the calculator and 18 to the second power, and we're going to rewrite those. So 24 squared becomes 576. 18 squared becomes 324, and you're going to still write that equals C squared. You're just bringing these down. We're bringing those down vertically. Next thing I'm going to do is add these two together, and I end up with 900 equals C squared. Now, the number one mistake is to say that somehow this is 900 yards, and there's no way you could fit something that's 900 yards in between these 2 points. So what you've forgotten to do is undo the squaring. That's the final step. We're going to take the square root of 900, also a perfect square, and we're going to remember to put our units back in. So between this point and this point is 30 yards, and boy, does that make a lot more sense than 900. These are the 4 steps that you must show when you're doing Pythagorean theorem. Substitute, square, add, take the square root, put the units in. Okay, so that's how you're going to defend your answer. That's how you're going to justify your answer. Final answer, in this case, 30 yards. Okay, are you ready to try a couple on your own? Okay, so on page 415, independent practice, we're going to try number 1, and then you can come back when you have the answer, and then we'll try number 6 in a second. Okay, let's see how you did. Now let's make sure your work should match mine. So the 5 and the 12 need to both be squared and added together to equal that C squared. This should be your first line of work. If you happen to have put the 12 squared in front, that is the same thing because addition is commutative. The order doesn't matter. 5 squared in the calculator, 12 squared in the calculator, we're going to replace those. So this becomes the 5 squared, which is 25, and the 144 takes the place of the 12 squared, and we still have equals C squared. That should be your second line of work. You're going to add these two together, and again, we've got a perfect square. So we take the square root of 169, only looking at the positive or the principal root, we've got 13. And did you remember to put your units back in? To get 100%, all the credit, you would need to show these 4 lines the way they're written on the screen. Okay, so the next one is not going to end up being a perfect square. So in the end, we're going to need to round to the nearest tenth, which would be 1 place, 1 decimal place. Okay, so pause the video, and you got huge numbers here, guys. So don't be surprised. It's the state of Wyoming. So you're going to find crossing diagonally across Wyoming what this distance is. So they gave you the 365, they gave you the 275. And again, we're going to assume that this is a right angle. This is a right triangle, okay? Pause the video and see if you can find that diagonal. Okay, let's see how you did. Did you take 375 to the second power plus 275 to the second power, and that will equal that diagonal to the second power? We're now going to pick up our calculator. 365 to the second power is a whoppingly huge 133,225. 275 to the second power is 75,625. So the 365 squared plus the 275 squared still equals c squared, and that's your second line of defense. I'm now going to add these two together, and we've got 208,805 equals c to the second power. To undo that second power, we are going to need to take the square root of 2,008,850. And when we do that on the calculator, you'll see 457.0010 and other numbers as well. But if we're going to round to the 10th, it'll actually look like this was a perfect square because it'll come out to 457 miles-ish. Next up is to turn our thinking around. And what if we knew what the hypotenuse was in one of the legs? How will we find the missing leg? Now remember, to find the hypotenuse, we took the leg squared plus the leg squared equals the longest side. The hypotenuse is always the longest side. So now if you're given the hypotenuse, you're not going to talk about adding to it to get to one of the other sides. You're going to have to subtract because he's the longest. So if you're given the number for the hypotenuse, he is going to lead the way in a subtraction. We're going to take hypotenuse squared minus the leg you were given, it doesn't matter which one, will give you the other leg squared. So when the hypotenuse is there, he leads the way in a subtraction. Now in your book, we're going to do example 2. You're going to notice I'm crossing it out because they're going to always use the a squared plus b squared equals c squared and do a subtraction kind of in the work. I'm going to start by letting the formula have the subtraction. So look over here, guys. There's the leg, there's the leg. Trace the right angle. There are your A and B. This is your C. Oh, they gave me the number. He leads the way in the subtraction, okay? So hypotenuse squared minus the leg given squared has to equal the other leg. Now the steps are going to kind of look the same. 24 squared is 576. 8 squared is 64. But this time, I'm going to take that hypotenuse squared minus the leg, which is 512. And when I take the square root of that in the calculator, it rounds, like we talked about in the last one, to 22.6. I put my units, which is meters, and I give the squiggly equals, the approximation symbol, so somebody knows that I rounded. Okay, so we're going to let you, or rather, I'm going to let you try that B. And once you've done B, come back. Let's make sure he's right before you do C. Okay, look at this. Trace your right angle. There's your A and B. Oh, darn, the leg's missing, but the hypotenuse is there. If the hypotenuse is given as a number, he leads the way in a subtraction, okay? So 8 squared minus 3 squared equals that missing leg squared. I square 8 and get 64 minus the 9, which is 3 squared. I take my calculator, and don't forget, right equals b squared. Just keep writing what's down. And now 64 minus 9 becomes 55. Square root of 55 is an irrational number. It is not a perfect square, so we're going to have a long decimal. I'm going to round it to a tenth. And when I round it to a tenth, it is about 7.4 miles. And I give the squiggly equals, the approximation. I mean, if we think about it, 55 on the perfect square trail was between 49 and the, which is 49 is 7 squared, and the 64, which would be 8 squared. So you'll notice that his square root is in between 7 and 8. We talked about that quite a few lessons ago. So you can kind of already have an idea before you take that square root to kind of make sure you didn't hit the wrong button in the calculator. Okay, final try, guys. Can you do this last one? And don't forget to show the substitution, the squaring, the subtraction or adding, depending on what you're given, and then the square root with your units. These are the 4 kind of lines of work you should be showing. Okay, did we get the hypotenuse this time? Trace your right angle. Okay, so we're missing one of the legs. We've been given the hypotenuse. He's opposite the right angle. So he's going to lead the way in a subtraction. 20 squared minus 17 squared equals the missing leg squared. Square it, write down, and don't forget to put equals a squared. Subtract 400 minus 289. Pick up your calculator. Don't stop here and say it's 111 centimeters. Don't forget to undo the squaring by taking the square root. And we're going to round to the 10th and put our units in. Should have gotten 10.5-ish centimeters. Let me just tell you some of the mistakes that can be made. The very first one is to use adding when you should be subtracting or vice versa. Remember that if the hypotenuse has a number, he leads the way in the subtraction. Otherwise, it's the 2 legs squared adding to get the hypotenuse. Second mistake is to not square at all. And the last mistake, as I've mentioned a few times, is to stop and say that the answer is here and not take the square root. And finally, so many people forget to put their units in. So today we're discovering how to use Pythagorean theorem to find the missing side inside of the triangle. And we basically have 2 forms of it that we use. If we're missing the hypotenuse, we're going to add the 2 legs squared to equal the hypotenuse squared. And if we're given the hypotenuse, we know its length, he's going to lead the way in a subtraction. So it'll be hypotenuse squared minus the given leg squared equals the missing leg squared. And that's how we're going to start working with Pythagorean theorem. I hope you guys all have a great day.